Hi, Math 30s. Um, this is your first lesson for set theory. So what you hopefully have done already is printed off the booklet from D2L. It has, again, your notes, your blank notes that we'll be going through, as well as the practice questions that you'll need. If at any point you again, if you don't have access to a printer, let me know. I can get it printed at school and then you can pick it up. You just need to give me quite a bit of lead time because Dawn and or Eric needs to print it if I can't go in, and then you need to make sure that they're available when you're able to come by to make sure that you can get it. So let me know in the future if that's what you want to do. So set notation. You have the timeline for how we're going to operate this unit. So let's get started with the first lesson, set notation. So it says, in this unit, we will learn how to organize objects in specific ways. Guys, I'm not on my smartboard. I'm on this funky tablet that should be better, but it's not. It's hard. So when things get wild, know that my haunted smartboard maybe isn't so bad. So again, organizing objects in specific ways. So when we're talking about objects, it's not like tidying your room. We're going to be talking about data sets or different pieces of information like that. So a collection of objects is called a set. And we use the notation. I'm just going to call the notation fancy brackets. Oh, I didn't draw that one really well, but you know what I mean by the fancy brackets. So that's saying what's included within a set. We're going to use the fancy brackets. Let me draw it big up here. Get really good at fancy brackets like that. That looks amazing. Each individual item in a set is called an element. So the first one that we'll do here, it says consider the English alphabet. It's made up of consonants and vowels. We can organize the set by using the following. So we can talk about the set of vowels. So I'm going to call that V. So the set of vowels would include A, E, I, O, and U. Those are all elements within the set of vowels. Yeah, freak out and say sometimes Y is a vowel, whatever. Get over it. We'll do A, E, I, O, U for now. So our consonants, so again, consonants are things that are not vowels. So it would be the elements B, C, D, F, G, H. I'm going to run out of room. You can keep writing it or you can get lazy like me and go with X, Y, Z. So that's getting to our consonants. We could also say all letters. So we'll call, oh, I'll name that in a second. So all the letters of the alphabet would be the elements A, B, C, D, dot, 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 X, Y, Z. So there would be 16 elements within that set. So just, I don't think I really wrote this anywhere, but there are 5 elements within our set V. There are in total 21 elements within our set C, and within set U, we'll talk about why we called it U, there are 26 elements in there. Again, I didn't write them all out, maybe you did. That's awesome. So set U is called, the reason we're using the letter U there is called the universal set, because it includes all possible elements. So for the English alphabet, this is all of the letters that we have. So all possible elements within it. So on to the next part here. It says, what can be said about the elements in set C in relation to those in set U? So where's my pen? There we are. We can say that everything in C is also in U. Same thing with the elements in set V in relation to U. So everything. Again, what I mean by everything is all elements. Everything in V is also in U. So when all elements in one set are included in another set, we say that one set is what's called a subset of another. So it's denoted by the symbol. It's kind of hard for me to describe what the symbol is. You can see it right here. It kind of looks like a C. It kind of looks like a U turned on its side. If it makes you uncomfortable, just make like a really long C. So that's our symbol that denotes subset of. So we could say what this is saying, C is a subset of U. We could also say that V is a subset of U as well. So again, that's because all elements in C are also in U. All elements in V are also in U. So that's what a subset is. That means that everything within it fits within a bigger set. What can be said about all of the elements in set C and set V? They do not have any elements in common. So are there any elements in both these sets? No. If we had said Y was a vowel and sometimes also a consonant, then it would be a different story. But based on how we defined it up above, they don't have any elements in common. So there's nothing that's consonant that's also a vowel. So when none of the elements in one set are included in another set, we say that these sets are disjoint. If we wrote out the number of elements in this set, we would have the empty set. We'll talk about empty set stuff later, but if we're saying that these two things have nothing in common, the set of them is empty. There would be nothing housed within it. So, does my next page have that? Oh, yep. So it says write all of the elements that are not in C. So everything that is not a consonant. So everything that's not a consonant. So that would be, again, A, E, I, O, U. Those are all things that are not within that C. Again, looking up at C is consonants, so everything that's not in there. So the elements are of this set that we've written above, so not in C, is called the complement. I think complement is like saying something nice, but this is complement of set C and is denoted by C, we call it C prime. It's kind of like a little apostrophe basically is how it looks. So this is saying when we see C prime means not in C. So the next part that it's saying here, it says what would happen if we added the elements in set C. So if we had set C and we added all the elements in C prime. So the elements in set C, again, were B, C, D, F, G, blah, blah, blah. If we added the elements in C prime, this is C prime, A, E, I, O, U, we would have everything. We would have A from the complement to C, and we would have B from here, and C from here, and D from here, and E from here. So what we would actually end up with, the universal set. And so again, that is all elements. Because if we're saying everything that's in C and everything that's not in C, Well, that's going to be everything then. So whenever we add a set and its complement, so a set and its complement again, denoted by that prime that looks kind of like an apostrophe, we will receive the universal set. How many elements are there in set V? So set V was vowels. So how many things are there in V? So this is a counting thing then. If you count A, E, I, O, U, there are 5 elements in set V. When asked to write the number of elements in a set, the textbook, and I think one of the worksheets actually does this, so just if you see it, it'll say NV. So if it says N before it, that's just asking the number of elements within set V. So just if that pops up and you're confused as to what NV means, that's what it's looking at. A Venn diagram. We're going to get to Venn diagrams in a bit, but we're going to look at another example question here. It says, consider the set of whole numbers. So this is kind of back to 10C. So whole numbers from 0 to 10. So whole numbers, again, includes the number 0, and it include all of the positive integers beyond 0 as well. So it says, let E be the set of even numbers, let O be the set of odd numbers, and let N be the set of natural numbers. So natural numbers, it's like a whole number. Natural numbers don't include 0. Just if you don't remember back to different numbering organization systems. So our set of even numbers would be 2, 4, 6, 8, and 10. We would include 10 and we would include 0. We can't call 0 a whole number, or sorry, an even number because it's not actually divisible by 2. So we wouldn't include it within even. Our odd numbers would be 1, 3, 5, 7, and 9. Our set of natural numbers, again, is whole numbers except not 0. So we'd start with 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the only other thing that it doesn't really include, I don't see it anywhere here, is our universal set. So our universal set is whole numbers from 0 to 10. So our universal set would be 0, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10. So just since it doesn't directly ask us that, but that might help us for the next little bit. So list the complement of set E. So again, a complement, the way we write it is E prime. So the complement to set E is everything that's not in E that is in the universal set. So looking at our universal set, anything that's not in E. So we know it's going to be our odd numbers, but it's also going to be 0. So 0, 1, 3, 5, 7, and 9. Because again, those are our odd numbers because those are not even with 0. So again, and not with, it's within the universal set, but not within the even numbers. So list any disjoint sets. So disjoint sets again are sets that don't have anything in common. So E and O are disjoint. And again, that's because they have nothing in common. We couldn't say anything else is disjoint because we couldn't say something like E and N are disjoint because they share some elements. They share the element 2, so we can't say that they're disjoint sets because they do have things in common. Do I have that little chart? Oh yes. Okay, so based on that, so this is telling us a couple of different things. So again, this shape means subset of. So E is a subset of the natural numbers. So that's saying is everything that's in E within N. And if you look, that is true. Everything in E is in the set of natural numbers, or set N. E, oh, sorry, I realized before. Let's go back a page. I called this universal set, but it really right here, I called it U, but it should just be W. That looks like a weird shape. But the set of whole numbers being W is the same as our universal set. So just because it has a W on this next page, that's why it was confusing. So E is a subset of W. Also true. Everything in E is in W. W is our universal set for this particular question. E prime, so again, that's the complement to E, is within W, or is a subset of W. This is still true. Everything not in E is in W. So again, everything that's not in E, so E was 2, 4, 6, 8, 10, so everything that's not in E is 1, 3, 5, 7, 9, but also 0. That's all within W. So absolutely. W is a subset of N. This is false. Not everything in W is in N. And so, again, 0 is not in N. So 0 is in W, but it's not within N. So we can't say that W is a subset of N. O prime, so this is saying the complement to O is equal to E. So everything that's not odd is within our set evens. And so kind of innately you would think, yeah, everything that's not odd is even, but the problem actually comes from that 0. So false. 0 is in O prime. Again, that's everything that's not in O. If you look back at what O is 1, 3, 5, 7, 9. So 0 would be within not O, or the complement to O, but it's not actually in our evens. So we can't say that they're equal because there's something that's in O prime that's not actually within the evens. So Venn diagrams, when you've seen Venn diagrams before, so up at the top, you guys are probably so used to seeing Venn diagrams. I have some good ones that are on the next couple of Smart Notebook files, so you can have a laugh. Jax, I know you'll have a laugh because you like bad puns. Venn diagrams usually represented by circles. Not always the case though, it doesn't need to be circles. You guys have seen Venn diagrams before, but using a Venn diagram to represent these sets. So usually when we do a Venn diagram, you'll do it kind of within a rectangle. So usually you call the full rectangle your universal set. So we define that as W up above instead of just U, and that's fine. So our next biggest set is actually going to be natural numbers. So a lot of times you guys want to do the two numbers that interconnect like that because you think that's the only way a Venn diagram can look, but that's not necessarily true. So our whole numbers, again, that represents 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So within that, the next biggest group is, oh, I wrote off the page, is our natural numbers. So I'm just going to write that kind of right here. So our natural numbers is housed within or is a subset of our whole numbers. But the only thing that's not actually, so again, if we had all those numbers, the only thing that's not within natural numbers is going to be the number, I'm going to write the word 0 just so that's not confusing, but 0 is a whole number but not a natural number. Then within that we could also have our even numbers and our odd numbers. They have nothing in common, so we're not going to cross them over like this. There's nothing in E that's also in O. So you could, again, we wrote the 0 here. You could write your appropriate numbers that even are 2, 4, 6, 8, 10, and this is 1, 3, 5, 7, and 9. So we've covered all the numbers that are within our universal set or our whole numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in our natural numbers, all of these are actually part of the natural numbers because E and O are both a subset of them. So hopefully that makes sense for the Venn diagram to represent the sets. Oh my gosh, one more page, lots of jabbering. So Johan drew the following Venn diagram and describe the sets as follows. So C, it looks like C is kind of our universal set for this piece of data because again, for the Venn diagram, we draw our big rectangle and that represents our universal set for this data. So C is our universal set. So that's produce. And so it looks like we have fruit and vegetables as two of the sets. And within that we also have, so within fruit, there's fruit that you can eat without peeling. Yeah, don't start getting all fighty that some things are fruits and some are vegetables and you could eat it without peeling, but you'd get sick. Let's just go with our most straightforward definition of this. So looking at that, so within our set vegetables, we have peas, corn, carrots, potatoes, and beans. Within our set fruit, we have bananas, pineapples, oranges, apples, and pears, but apples and pears are within that subset of fruits you can eat without peeling. Yeah, eat a banana peel, whatever, that's gross. Let's not do that. So it says the number of elements. So again, when we're saying the number of elements, that's saying how many within V. So based on the information that they've given us, you might be able to name some different vegetables, that's fine. But based on the information that they give us, there are 5 elements in V. List any disjoint sets. So disjoint sets, again, are things that don't have anything in common. So V and F are disjoint. Again, that means they have nothing in common. You could also say that V and S are disjoints because S is still a set and it is disjoint to V because it also has no elements in common. You can't say F and S are disjoint because these things in S are also in F, so you can't say they're disjoint, but V and F being disjoint is the big thing. It says, is F prime equal to V? So this is saying the complement to fruits equal to vegetables. So is it equal to V? This is kind of a two-part question that we could answer it. So we could say if these are the only items of produce. So since it doesn't tell us anything outside of these little circles and ovals, so since there's not something out here that's a different type of produce, then yes, but the other thing is um, there are lots of vegetables that are not listed in V right now. V, so kind of no, kind of yes. You can sell me on both of those. So list all of the elements that are in S prime. So again, that's the complement to S. So that means not in S. So things that are not in S are, again, the way we'll write that, so S prime, I kind of wrote that as S1. So S prime would be peas, corn, carrots, potatoes, beans, and also these things that are in fruit that are not in S. So oranges, pineapples, bananas. So yeah, so a couple different, oh good, um, terms that we've kind of used. We're going to get a lot of different symbols and sets of words that we're going to need for this one, so these summaries will do it. So I always just call them fancy brackets, but they're actually called braces. So fancy brackets or braces are used to define a set. The symbol stretched out C means one set is a subset of another set, meaning that all of the elements in that one set can fit within the other set. A Venn diagram is an easy way to graphically show sets. Two sets are called disjoint when they have no elements in common. The complement, again, A prime, is the set of elements that are not within that particular set. So the complement of A is things that are not in A, but are within your universal set. All elements of all sets gives us the universal set. And the textbook, oh, again, sometimes uses NA, so that's saying the number of elements in set A. I know most of you guys don't have a textbook. A couple of you guys did sign them out, but just if you see that, make sure you keep an eye on it. So your homework is the next couple of pages. I think it should be 3 pages in your workbook until you get to the next lesson that's called OR and Venn diagrams graphs. So 3 pages of practice notes. Again, my key will be on D2L, so you can have a peek through and see if everything makes sense. And let me know if there's anything you need. Okay, bye.